Thank you. Good morning, ladies and gentlemen. It's another bright Saturday morning for another session of capacity building. We appreciate everyone who has been joining us consistently, and for our new joiners, we do appreciate you as well. My name is Anu Oluwapo Afolabi, and I will be moderating the session. This weekly webinar is organized by Plus-CircleCommunityHealth Advancement Organization. As the name implies, it is a non-governmental organization hinged on promoting school health, community health, and evidence-based research to drive policy changes and program adaptation. We kindly implore you to please follow us on our social media platforms, including but not limited to LinkedIn, Facebook, and Instagram, for timely information on this and similar events. In addition, kindly subscribe to our YouTube channel, where all our webinar recordings are uploaded. During the session, we will share the link to the channel so that you can subscribe. Do expect an email from us later in the day that contains a summary of today's session, as well as the link to our social media platforms. Okay, without further ado, I'll proceed to introduce our speaker for today. Our speaker is Dr. Olayinka Stephen Ilesomi. He's been here with us a couple of times to share knowledge with us. He's a public health physician and epidemiologist by training, with over 15 years of professional experience. Dr. Ilesomi is a teacher who is committed to transferring the knowledge and skills he has acquired to younger professionals. He is an editorial board member to many journals, including the Journal of Public Health in Africa and the Journal of Health and Social Sciences, to mention a few. He is also a reviewer for many local and international journals, including BMC Public Health, and he has published more than 350 articles in many high-impact factor journals. In addition, he is a statistician and an expert in the field of data analysis. As the session progresses, you may use the chat box to send in your questions. Alternatively, you may wait till the end of the presentation, where we'll have the Q&A session, wherein you'd be allowed to ask your questions directly once you use the hand raise icon. Participants are muted as they join, and we would like us to stay mute until the Q&A session. This helps to prevent distractions as much as possible. Without further ado, please welcome on stage Dr. Olayinka Stephen Ilesomi. Dr. Ilesomi, over.
Yeah, good morning. I hope I'm audible now.
Yes, you are.
Okay, thank you so much. So I am trying to share my screen so that we start right away. So thank you for the beautiful introduction, and I want to appreciate colleagues that are already on the call to join us. So just as it has been mentioned earlier by the moderator, today we'll be looking at utilizing the right statistical analysis to address your research questions. I want to believe that many, if not all of us on the call today that joins the meeting, all of us have one research or the other that we are working on, or maybe we are trying to start a research project or work. So this is going to be a timely opportunity for you to have your questions answered, and at the same time, you can also contribute to the discussion. So thank you once again for joining. Now, I'll be using the following outline. I will give a brief introduction to the topic, then we talk briefly about statistics. And I promise not to scare you with statistics this morning. And then we are going to look at univariate, bivariate, and also multivariate analysis. So as a way of introduction, when you have appropriate statistical analysis, it helps in answering your research questions effectively. I've read a few papers or a few drafts from colleagues whereby people have a good intention, but the way it was executed was actually not proper. I hope you understand what I am trying to explain. They want to answer a very good question, probably a novel one that probably nobody has answered, but the way they go about it, using the wrong statistical analysis and so on, it makes it a bit difficult for people to accept what they have done. Now, when you use the appropriate statistical analysis, it also prevents misleading conclusion. You don't want to conclude what is not right. You want to give the exact conclusion. And at the same time, the impact and validity of your research is increased. It helps you to strengthen the impact. When you say, oh, you have done the right thing, and then what you are telling us to believe or to understand, it will be clear, and it makes your research more impactful. And at the same time, it ensures your analysis is tailored to your research questions. I've seen a few colleagues in the past. The research questions they intend to answer is something that could be answered using a descriptive statistics, but they just want chi-square, they want p-value, they want odds ratio, they want confidence interval. And sometimes this may not really be applicable based on the research questions that they intend to answer. Now, I would also like you to understand the fact that when you define your research questions and objectives properly, it helps you to clearly understand your goal. What do you aim at achieving? Are you exploring relationship? In some research objectives or questions, you may want to compare groups, maybe a rural-urban comparison of catastrophic health expenditure in a particular state, probably in Nigeria, or in a particular region in Ghana, and so on. Now, it also helps in exploring relationship, comparing groups, and predicting outcomes when your research questions and objectives are properly and well defined. Let me give you an example. Are you trying to determine if a new intervention reduces disease incidence, or you want to identify factors associated with health outcomes? You need to define this in your research questions and objectives so that it will guide you and tailor your analysis towards achieving your aim. Now, the next slide will clarify this further. I want every one of us to look at this slide. Now, if you know that there is a difference in the way to approach these two, you can just put, no, let me just answer my question. Are these questions the same? Now, you just give me a yes or no on the chat box. A yes or no on the chat box as we continue. I've asked a question. Okay, thank you, Prince. Prince said no. So I'm waiting for others. The questions, Prince said it's not the same. Okay, there is a doctor. Okay, many people are saying no. Well, if you think it is not no, I still want to see your hands. I want to see your response. I've received response from Eric, from Ojo, from Yesuru, from Simiat. Okay, Dr. Jitse, my beloved brother, and several. Okay, thank you so much. I think we can stop it now. Good, 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 good. I think we all said no.
Just a minute. Seems our speaker has some internet connection issues. I'm sure he'll be back in a moment. Okay, so while we await his return.
If we have time, maybe one or two of us may need to.
Okay. Okay. So while we await his return, I would like to ask someone to please tell us the reason why he or she thinks the questions are different. Before I hand over back to Dr. Elisomi. Abubakar Yakubu, can you unmute and tell us why the questions are different or what you think is the reason? Abubakar Yakubu.
Okay, someone is sending a response on the chat. From Olayinka Ibrahim, he said the outcome is different. Thank you. I will note that. Let me share back my screen. I had some internet glitches at the point, but I'm resharing my screen now. Yeah, thank you so much. I'm back. So the question is, are these questions the same? One of my colleagues here have said that the outcome are not the same. So that means Okay, fine. Prince Sepesi, sorry if I don't pronounce the name well. Now, I say one is looking at mean difference and the other one is looking at prevalence difference. Thank you so much, Prince, for sharing that with us. Now, Azan is telling us that the first one mean difference and the second is prevalence difference. Thank you. Now, the question looks very simple, and it is indeed. But when it comes to the time of executing our own research, maybe we forget some of these things because I've had to review articles in the past for journals, and I noticed that people miss up this very simple and easy concept that has been identified by many of us on the call. Now, the first one says, is there a difference in the mean blood pressure levels between doctors and pharmacists at General Hospital, Ikeja, Lagos? The second one says, is there a difference in the prevalence of hypertension? Now, I agree with my colleagues in the meeting that have shared their thoughts that the first one is looking at mean difference, though it wasn't specified, maybe mean systolic blood pressure. You know, when you measure blood pressure, for the sake of those of us that are not in the health sciences, you have two readings, usually one upper and one lower reading, something over something, whereas you have the upper reading that is usually higher than the lower reading, and the upper one is called systolic blood pressure, and the lower one is called diastolic. That's for the sake of my colleagues that are not in the health sciences. So let's specify now. Let's assume we are saying a difference in the mean systolic blood pressure. That means all the upper reading, we want to take the mean value for all the doctors at that particular hospital. Now, let's assume that the mean value for all the doctors in that hospital ended up being maybe 125, for instance. Now, we took the same for all the pharmacists, and the mean value ended up being, let's assume it is maybe 120. Now, the doctors' mean BP or blood pressure, systolic blood pressure now, to be specific, at least one of the two. The doctors ended up with 125, and for the millimeter of mercury, and for the pharmacist, you have 120. So just like colleagues have said, we are comparing mean. Now, for the second question, is there a difference in the prevalence of hypertension between doctors? This time around, we are not looking at mean. Our outcome is prevalence. How many doctors are hypertensive? How many pharmacists are hypertensive? Let's assume that we have studied maybe 100 doctors and 100 pharmacists. And out of the 100 doctors, maybe 10 of them are hypertensive. Now, out of the pharmacists, let's assume that 6 or 7 of the pharmacists are hypertensive. So now we are looking at the proportion, unlike the other one. We are going to be more specific with time. So let's just move on for the sake of our time, colleagues. Now, I want us to look at factors that influence statistical analysis. We have 4 factors that I've listed here, but they are not limited to these 4. The first one is research questions. Now, we have seen an example of research questions in the previous slide, whereas 2 similarly measuring the same statistic or the same parameter, but the way the questions are framed, the way you need to answer the questions will actually affect the type of statistics that you need to introduce. Now, exposure and outcome variables. Someone told us in the other question that we don't have the same outcome. Sincerely, true, I agree. The outcomes are not the same. So what you are looking at, your outcome, or now it could even be the exposure, your starting point. It could also mean a difference in the type of analysis that you need to do. Now, another thing is the study design, the way you design your study. You can do the same thing, but because of different study design, it will definitely have a way in affecting your analysis. Now, the sample population, or let me say the population you are studying, or at the same time, the size of your population, it also has a way in affecting the type of analysis that you do. If you are studying a very small sample, then some analysis type are not feasible or they are not advisable. Now, if you are studying a large population size, more than 30, more than 200, more than 100, and so on, then you may need to actually do some kind of analysis. We are going to examine a few of that in the next few minutes. Now, I want to just speak about the last slide for a few seconds or minutes. We have seen the example of research questions, how it affects the type of analysis that we do. Like the first question, we're looking at mean difference. So subsequently, we are going to look at what do you use in determining mean difference. The other one, we are looking at prevalence difference. What do we use in examining difference in prevalence of two outcomes? We are going to consider that briefly. Now, I want us to examine dependent versus independent variables at this junction. Now, when you look at dependent variables, what are they? They are the outcome of the study that you are carrying out. For instance, in the previous example, the outcome is either the mean blood pressure or the prevalence of hypertension. That is the outcome where you are going. And you may have two different outcomes, maybe a primary or a secondary outcome. The primary outcome is also referred to as main outcome in your study. It is primary or main outcome. That is where you are going to at the end of your study. What do you want to tell us? Maybe you have introduced antihypertensive drugs into two different populations. Let me still continue with the initial example. You have given some doctors antihypertensive drugs. You have given the same drug probably to a group of pharmacists, and then you want to look at the rates at which the drug is going to lower the BP lowering effects of the drug. That may be the main outcome of that study. However, maybe after using the drug, some of the patients complain that the drugs probably makes them sleep more. You may want to examine, oh, why? Let's see the effects of this drug on the duration of sleep or the pattern of sleep and so on. So that is actually not the primary outcome of your study. But in this instance, that is more like a secondary outcome. It's not the main thing that you're looking at. You are looking at the BP lowering effects of a particular drug X. But now you just felt, oh, people are complaining, people are telling you that, oh, the drug is making them to sleep more. You now want to look at how much or how many of them will sleep more, how long are they going to sleep, and so on and so forth. So that is about our dependent variables. All these simple terms and definitions, they are very important when it comes to deciding on the type of analysis that we need to carry out. Now, let's look at the independent variables. The independent variables can actually be called the predictor. When I started learning epidemiology and statistics, the way I normally explain it to myself is that independent variables are predictors, or they are as well the starting points. Like that is where you are starting from. For instance, in my previous example, we are starting from professional category. We are starting from professional cadre, being a doctor or being a pharmacist. That is the starting point. That is our independent variable in this particular example. Now, the outcome, we have already talked about that. Apart from using the term independent variable, people can also use the predictor factor or the predictor variable. They are essentially the same, as depending on the type of study design. So we're going to move on now. Now, we need to also mention one or two things about statistics. As I said, the reason for this session is not to bore us with statistics and to put in a lot of figures, but I want to make it as simple as possible. Now, broadly talking about statistics, it deals with collection, interpretation, collection, analysis, processing, and interpretation of data. So that's what statistics is. And at the end of the day, you want to apply the knowledge you've acquired. You want to apply it to solving a particular problem that you have identified. Everything starts from a problem. Anyways, you need to be interested in solving a problem. Now, when you divide statistics broadly, we have two different categories, and they are simply descriptive and inferential statistics. Descriptive means a statistic that helps in summarizing your data. So when you want to summarize your data, there are two different types of descriptive statistics that are commonly used. We have the measure of central tendency and measures of dispersion. Those are the two descriptive statistics: measure of central tendency and measure of dispersion. Now, when you talk about measure of central tendency, they are what allows you to know the location of your findings, of your results, of your data, the location compared to the population. The population in this instance does not mean maybe the total population of people living in Monrovia, total population of people living in Lagos. No, that is your sample size, your frame, how many people are included. In the population where you have removed your sample size from, how do you situate your finding? We are going to discuss this further. And inferential statistics, it makes decision about a research question, inquiry based on data collected. Inference means you want to make like a deduction. Simple English, all men are mortal. And you now mention that Olayinka Ilesanmi is a man. I don't think I need to tell you the last sentence before you make up your mind. When I said he is a man, all men are mortal, then what do you expect? He's also mortal, kind of. So inferential statistics helps you to make inference from what you have found. Now, in my previous example, we looked at a group of pharmacists and also a group of doctors, and we are trying to look at prevalence of hypertension. Now, having seen your results, now you may want to make inference that, okay, maybe doctors are more likely to have this, probably pharmacists are more likely to have this or thereabouts. So inferential statistics, in summary, makes decision about a research questions, whereas descriptive statistics. So let's have these two at the back of our mind in understanding the type of statistics that we need to use in solving problems or in answering our research questions. Initially, I've talked about the type of statistics that you have, the summary and the inferential, and at the same time, we have looked at outcome variables, independent variables. All these will guide us in the subsequent slide. Now, you also need to understand how data are classified. It doesn't have to be medical data. I use medical data because that's actually what I've used in the examples in the session for today. Now, how do you classify your data? You need to understand this because by the time you look at your outcome, we have defined what outcome is. By the time you look at your independent variable, we have talked briefly about what that is. By the time you look at the type of statistic, probably descriptive or inferential, we have also mentioned that in a jiffy. Now, you need to know the classification of the medical data. Now, let's look at the numerical dimensions. We have two different types of classification, and your data is either quantitative or qualitative. Now, when we talk about quantitative variables, the word quantitative starts with quantity. That means you want to measure, you want to give a numerical value to a particular event or a particular phenomenon. Now, if you measure somebody's weight, if I ask you probably on the word, if someone said, oh, can you help me take the reading or measurement of that patient's weight? At the end of the day, the person is expecting you to tell him or her that, oh, the weight is 80 kilogram, maybe 60 kilogram, 40 kilogram, and so on and so forth. The person is not expecting you to say, oh, the weight is high, the weight is low. That may not necessarily be the expectation most time. Now, if I ask you, what is the height of someone, or what's your height? I'm expecting it either in feet or in meter square. Oh, maybe 1.75 or 1 point something meters, or maybe in centimeter, probably, depending on the age or the height. Now, all these are quantitative variables. You quantify things. You want to bring things out in quantity. You want to measure, and you want to record your reading. Now, quantitative variable can be organized into discrete and continuous. When we use the word discrete, we refer to whole number values. It means it may be 1, it may be 2, 3, and so on. But when it is continuous, it means it may take decimal values, like height in meter. I mentioned earlier that height could be 1.73 meters. That means it is a continuous quantitative variable. So under quantitative, we have both continuous and discrete. Now, let's also look at qualitative variables, quality. In qualitative variable, we don't assign numbers particularly. We don't assign quality. Sorry, we don't assign quantity, but what we assign is like quality. If I ask you, about for instance, if you use the stage of liver cancer, even though we can assign maybe 1, 2, and so on, but the stage is talking about the quality, how good or how bad is the liver at that point. Now, if you look at types of oral hypoglycemic drugs, the types too, we are not talking about just quantity, we are talking about quality. And a simple example is gender. When we assign numbers to these variables, the number does not have numerical value. I want you to take note of that. For instance, if I'm doing my data entry and I assigned 1 to male and I assigned 2 to female. Now, assigning 1 to male and 2 to female, it doesn't mean that 2 female makes up 1 male, or 1 or 2 males make up 1 female. No, the number does not have a numerical value or characteristics. Likewise, the stage of liver cancer. If liver cancer is in stage 1, stage 2, it doesn't mean stage 2 is double of stage 1. It's just like a form of progression. Oh, this is where it has gotten to. Then we tag it as stage 1, and so on and so forth. And it can also be classified based on number of categories of variable. You can dichotomize qualitative variable. Like gender can be dichotomized into male or female, the norm. Male, female. We can have some other category, but male, female is common gender that we have. Now, male, you can assign a particular number. Female, we can assign a particular number. Now, if it is multicotomous, that is, it is more than dichotomous, we have multiple categories, more than 2. For instance, blood group, we have A, we have O, we have AB. Let's limit it to that. That is more than 2. You can assign 1 to blood group A, 2 to blood group O, 3 to blood group AB. It doesn't mean blood group A, blood group O is twice of blood group A, and so on. The number you are assigning, it doesn't have numerical value, or it's of no numerical importance. I believe that is clear. So for qualitative variable, no numerical significance or importance. But for quantity, the numerical value, it means something. If my weight, or if someone's weight is 80 kilograms and another person's weight is 40 kilograms, the person whose weight is 80 is twice that of 40. Unlike the number that we are assigning in qualitative variable, that number is just to categorize them, to put them into categories or into groups. That is what is all about it. Now, I want us to go straight to 3 different types of analysis, which is univariate, bivariate, and multivariate analysis. I told you earlier on that univariate analysis are most times used for summary statistics. They are used to summarize things, just to have an idea of one single value, or how does that single value, how is it positioned when you talk about the general population where the sample was taken out of. Now, for quantitative variable, if your sample is normally distributed, the most important and useful measure of central tendency that you will use is the mean. Now, I mentioned a term that if your sample is normally distributed, what do I mean by something being normally distributed? I would like to talk about that briefly. I want to give an example. If you want to find the age, you want to find the mean age of the pupils in a particular nursery school, maybe they are in kindergarten class. And in that particular class, we have 10 pupils in that class. And you are finding their age. Maybe pupil 1, the age is maybe 3, pupil 2, the age is 4, pupil 4, pupil 3, the age is 3, and so on. Their age or ages, they are like 3, 4, 5, maximum of 5, between 3 and 5. Now, by the time you are finding your mean, if you mistakenly add the age of their teacher, let's assume that the teacher teaching that class, the age probably is maybe 30. The teacher is 30 years old. And, almost even the 10 pupils, when you add up their age, it may even not be more than 30 or maybe 35, or the total. But now that the teacher's age was mistakenly added, and you now want to find the mean is going to be skewed. The mean will be, because of the mistake that you made by adding the age of the teacher, the mean may be skewed, and then it will be far above what the age of that particular class should be. It will be far above that. That is like an example of a particular mean being skewed. Now, when your mean is not skewed, when it is normally distributed, they are within the same range, they are not too far from each other, then what you can do is to use mean as a form of summary statistics to summarize your age distribution. I'm using age as an example. It could be any other thing. Anyways, now when it is skewed, for instance, let's assume that that teacher was not, it wasn't a mistake. She was actually one of the pupils or one of the students in that class. Then what do? Instead of using mean to summarize, we summarize using median as measures of central tendency. Mind you, I mentioned earlier that the statistics are either measure of central tendency or measure of dispersion. So if you can't use the mean because your data is skewed, then what is allowable is the use of median. Now, for mean and median, remind you, these are quantitative variables, not qualitative. And I believe we remember what qualitative and quantitative variables are based on the previous explanation and based on the previous classes that we have also had. Now, when you want to summarize the mean as a measure of central tendency for a normally distributed data, the mean goes with standard deviation, which is the appropriate measure of dispersion. The mean will give you the central tendency. Where is it located? The standard deviation, the measure of dispersion, will tell you about the location. How is it situated in the population? Thank you. Now, if your data is skewed and you have used median as a measure of central tendency, then you need to use the range as your measure of dispersion. That means anytime you report mean, you have done your test and you report mean, then your mean must go with standard deviation. That's why you see mean plus or minus SD sometimes. Your mean must go with standard deviation. Now, when your data is skewed and you are reporting median, then your median must go with the range, which is the appropriate measure of dispersion for median. I've seen colleagues occasionally saying that, I want to put the mean and I want to put the median, whereas the data is normally distributed. Using the median should not, or reporting the range should not necessarily be, except if you have a point that you want to prove by doing that. So mean goes with standard deviation and median goes with the range. Now, going to qualitative variables, we use frequencies and proportions as the summary statistics for qualitative variable. Now, if the objective of my research question is to determine the prevalence of the prevalence of doctors who are hypertensive at Ikeja General Hospital, for instance. Now, I don't need the mean. I don't need the median, the range. All I need now is just frequency, because I am dealing with qualitative variable. All I need to report is 10% of the doctors, 5% of the doctors, just as the case may be. Now, if what I'm comparing, I'm talking about the two questions shared earlier in the session. If what I'm comparing is the mean systolic blood pressure of doctors and nurses, then my quantitative variable, my summary statistics will be mean and also the standard deviation. I will now be reporting that the mean blood pressure of doctors in that particular hospital is 125 millimeter of mercury, and the mean plus or minus the standard deviation, and the mean among the other cadre, the pharmacist, is 120 millimeter of mercury. I'm comparing the mean. Now, if I'm not doing any comparison, all I needed to do is to determine the mean. Then I don't need any p-value. I don't need any further statistics. ordinary descriptive statistics. I'm using ordinary because it's the first level. The descriptive statistics has already answered my question, and there is no need of maybe beating about the bush to do a lot of other funky things. So I want to do something that people will see that I've done something that is bogus or that is worthy and robust enough. No, your question is answered already. Now, let's move to choosing appropriate statistics test. We have said this earlier, but this is just like a form of summarizing a few of the things that we have mentioned earlier. Your variable type goes a long way in determining the type of test that you do. And we have talked about descriptive statistics tests alone, just the measure of central tendency and measure of dispersion. And we also talked about frequency, that is the proportion, frequency and proportion. Now, if your variable type is quantitative, we want to do summary statistics, I'm sure you understand what you can make use now. Now, if quantitative, normally distributed or not, it will also guide you in determining what to use. Now, if it is quantitative, quantity, and it is normally distributed, and you want to find the mean, you go for the mean. You want to summarize rather, you go for the mean. If it is qualitative, it's dichotomous or multichotomous, then we go for frequency and proportion. Now, your study design also play a very important role. You need to know what your dependent variables are and what your independent variables are. And we have explained this briefly earlier too. Now, also when your sample size is large or small, I have not really emphasized this, but I'm going to mention this briefly. When you have a large or small sample size, you need to also know the type of statistic that you need to use. Other assumptions underlying the use of the test statistics as linear tests must also be obeyed and thoroughly understood. Now, I've spoken briefly about univariate analysis. I want us to go to bivariate. When you say the word bivariate, bi means more than one. It is two, not more than one necessarily. Two, because it is bi. So bivariate analysis is the last level after your univariate analysis. I mentioned earlier on that 3 levels of analysis are very important: the univariate, the bivariate, and the multivariate. Regardless of how complex the research questions are, these 3 levels will definitely answer your research questions. At least your question may be answered just by doing your univariate analysis, and I've given you an example. Sometimes you may need to do bivariate, which is actually most times we do that. And on some other occasion, you may need to go ahead and carry out multivariate analysis. Now, bivariate tells us about the relationship between two quantitative, if what you are testing is the relationship between two quantitative variables, quantity, maybe height and the weight, you can use correlation analysis, correlation. That is, it tells you the strength of relationship between two different variables. We can look at the height and weight of pupils in a particular school. As the height is increasing, what happens to the weight? That is correlation analysis. Strength of relationship, like strength of association. How are they related to other? How are they associated? What's the strength? What is the relationship between them in terms of in terms of the correlation tells us about the strength of relationship between the two. Now, for two quantitative variables, I've used weight and height. At some age too, you may want to look at linear regression analysis. Now, what do we do by linear regression analysis? Linear regression helps us to predict one variable from the other. For instance, as age is increasing, let's say our age is Y. I told you I'm not going to introduce any statistical formula or the like. If the age is Y, for instance, how do we use the height, for instance, to predict the age? If that's what you are interested in. Or maybe let's use weight and height. So as the age or as the weight is increasing, what happens to the height? As the height is increasing, what happens to the weight? In this time around, we are not trying to look at strength of relationship. We are using one to predict the other. And I want to remind you, of course, we know that at certain age, as the height is increasing, the weight is also increasing. So linear regression analysis helps in predicting one variable from the other. Now, if your outcome are qualitative, for instance, proportion, we've talked about the central tendency and the use of descriptive statistics for that earlier on. For proportion, all you need to do is to use chi-square test in trying to look at two different proportion. You use chi-square test for that. So now, relationship between two qualitative. Let me give an example. You want to look at blood pressure among doctors and pharmacists. Your independent variable in this example is doctor and pharmacy. That's occupational category. Now, if you have the prevalence, hypertensive, yes, no. You have the proportion of the doctors that's hypertensive, and you have that of the pharmacist as well. You can now use chi-square test to determine the relationship between these two qualitative variables. The differences that you have seen, are they statistically significant? Chi-square test will do this for you. Now, if you are looking at relationship between one qualitative and one quantitative variable, you can reduce this to mean difference between two or more groups. Now, if it is to mean difference between two groups, for instance, the mean blood pressure, that was the first question I asked earlier. You want to compare mean blood pressure among doctors to mean blood pressure among nurses. All you need to, or among pharmacists, all you need to do is to use t-test if they are normally distributed, which I think they should. So you will use t-test. Now, if the groups are more than two, then you go for f-test, which is called the analysis of variance, because you have more than two categories. You want to compare mean difference between doctors, nurses, and you added pharmacists. That's three categories already. You have the mean, but what's the appropriate statistics? We go with ANOVA, which is also called f-test. So I'm going to give some other examples subsequently to explain when your data is normally distributed, what kind of statistics you use, and when it is not. But let's move to the next slide, which is showing us that the questions that are on this slide must be asked before you choose an appropriate test. One, you need to know if your data is normally distributed. I told you earlier that if you want to compare the difference between two mean, normally you compare mean when your data is normally distributed. Then you go for the t-test. Now, if that data is not normally distributed, you go for the non-parametric equivalence. And what is the non-parametric equivalent of t-test? That is Mann-Whitney-U. Don't mind the name, but the test is Mann-Whitney-U. Now, when I started learning statistics, the way I normally remember that is that after the alphabet C, t-test, the next alphabet is U. Then if T is not appropriate, if my data is not normally distributed, and I go to the U, so Mann-Whitney-U, that's on a lighter note. So the non-parametric equivalent of t-test is Mann-Whitney-U. So now I will show you a table that shows the parametric and non-parametric equivalents of some tests. Now, if dependent samples are involved, if you are involving dependent sample, then you may need to use paired t-test. For instance, you are comparing two groups, maybe a before and after. You assess the knowledge of, maybe before this session, we decided to assess your knowledge on the use of, on the appropriateness of statistical tests. And at the end of the session, we also gave you the same test. And now we want to compare before and after. Then we may need to use paired t-test, not just t-test. This time around, we used paired t-test. So understanding your research questions, understanding the distribution of your data gives a lot of guidance in determining what kind of test you need to do. Now, let's see the parametric and the non-parametric equivalents of some of these tests that I've mentioned. I mentioned independent sample t-test. When t-test is the most appropriate statistic to use, when your sample is normally distributed, you use t-test to determine the difference between two mean, two different means, mean age of male and mean age of female. Compare that using t-test. But now, when your data is not normally distributed, it is non-parametric, then you need to use Mann-Whitney-U test. I mentioned that earlier. For instance, if you're also comparing like a pre and post and so on, you use PLT test for parametric test, and you use Wilkinson sign rank test for the non-parametric equivalent. Now, most times, some of these names under parametric test, they are more familiar compared to the non-parametric, because sometimes when we are meant to use the non-parametric equivalent, I've seen a few colleagues still using parametric, despite the fact that their data are skewed, their data are not normally distributed. Now, when you are meant to use ANOVA, one-way analysis of variance for parametric tests, if your data set is non-parametric, you use Kruskal-Wallis instead of one-way ANOVA. Now, instead of using Pearson correlation, I mentioned correlation earlier on to determine the strength of association between two continuous variables. When your sample is not normally distributed, you go to Spearman's correlation analysis. So don't let us forget this. Most, if not all, the parametric tests, they have their non-parametric equivalents. Now, before we take questions, I would like to talk briefly about multivariate analysis. I've mentioned briefly univariate or descriptive statistics. We have moved to bivariate briefly. And now we are going to talk briefly about the multivariate analysis before we take a few questions, and then I can expatiate further if time permits. Now, multivariate analysis is a form of analysis involving one outcome variable and two or more independent variables or predictors. We have looked at one independent variable and one outcome. But this time around, when your independent variables, when they are more than two, or when they are two or they are more, then you are considering multivariate analysis. You are going to see an example soon. And it is employed when there are potential confounders, which may distort the true relationship between two variables of primary interest. When you have more than two variables, and you want to look at, I think, confounders and bias, I think we can actually talk about that in another sessions. But you want to remove the effects of potential confounders, then multivariate analysis will help you to filter out the confounders from your results. So we are going to discuss that in another session, probably not today. Now, the multivariate analysis is usually named according to the nature of your dependent or your outcome variable. For instance, you use multiple logistic regression when your outcome is dichotomous. And logistic regression is something that is actually often used during our research. But before you use logistic regression, ensure that your outcome is dichotomous. It is like a yes or no outcome. Hypertensive, yes, no. Use of oral contraceptive pill, yes, no, and so on. Now, you can also use multiple linear regression when your outcome quantitative variable is continuous. When your outcome variable is continuous, for instance, like you are looking at a continuous outcome, not necessarily categorical, then multiple linear regression. I mentioned earlier that linear regression will help you to predict one variable given the other. How much increase will height have as age increases at a particular point in life? Now, cost regression, it's talking about outcome. The outcome here is time to a particular event. When you are considering time to an event, like in Kaplan-Meier analysis and so on, survival analysis, you can use cost regression as a form of multivariate analysis. We can also have Poisson regression when your outcome is very rare. It happens maybe 1 in 1,000 or 1 in thousands or hundreds. Maybe when the event is very rare, then you use a Poisson regression. Now, briefly explaining logistic regression is used widely in medical research. I'm sure you all agree with me. And many outcomes in medical research are dichotomous. Like disease, it is either present or absent. Mortality, either yes or no. Now, it is appropriate for analysis of cross-sectional data and case control study. Those are the two most widely used study designs. Your most study design are cross-sectional followed by case control study. So logistic regression is widely used for this. And Rates cannot be calculated, hence odds of events are used in computation. When you are calculating your odds ratio, when you cannot get rates because your data is cross-sectional or case control, it is not a cohort study that you are doing, then you use odds of events. Odds talks about the likelihood of an event happening compared to the likelihood of the event not happening. That is the odds of events happening, and that's what you report. And that is also up to report. I've also seen a few colleagues reporting that the events, those in one category, they are 5 times likely to have an outcome compared to those that are not. That is more like reporting a cohort study using relative risk. But in this case, for cross-sectional case control, you report the odds. Now, in your logistic model, it's a model I promised that I wasn't going to talk about statistics too in details, talking about modeling and putting y equals to alpha plus bx and so on. But we need to talk about the model briefly. It describes the expected value of y. That is what your model does. When you see a linear model, the model used in logistic regression as well, it describes the relationship between your variables. And I think we are going to limit that. Now, when you also estimate your odds ratio, it quantifies relationship in a logistic regression. How many times is an event or a particular outcome likely in a particular group compared to another group of respondents? So I'm going to pause it here for questions and answers. I don't know if some are already on the chat box, but if not, I think I will give it back to Ms. Anoluapa Folabi to moderate the Q&A session. So thank you. If time permits, we can move on further. Back to you, moderator.
All right. Thank you so much, Dr. Ilesomi. Thank you for the amazing presentation. So we have a couple of questions here already. And the first one says, what if I have 2 outcomes of interest in my research? That is, contraceptive use and intention to use.
Okay, thank you very
Mrs.
much.
Moji, is the question clear, or would you want the person who asked to provide more
Can you
clarity?
repeat the question yourself? Can you come again with the question? Sorry.
What if I have 2 outcomes of interest in my research, and the outcomes are contraceptive use and intention to use contraceptives?
Okay, thank you so much for the question. Now, we don't really have time to talk about multi-level analysis. Now, one comes before the other. Intention to use. Then the next is use of contraceptive. So it is also a form of multivariate analysis. Having done your univariate and also your bivariate, then you move next to multivariate. And the multivariate here may be multiple logistic regression. You can do logistic regression, which is not binary because your outcome are 2. Or if you want to use binary, you can do multi-level analysis, whereby multi-level analysis will guide you in, you may want to look at those who have intention. And among those who have intention, you can move to the next level and also analyze for those who eventually use the so-called contraceptive. So that is more like a multi-level form of analysis, but it's still a form of multiple regression. I don't know if that explanation is clear enough to the person.
Yes, thank you. Thank you very much.
Okay, back to you, moderator. Okay, I can't hear the moderator. Maybe there is an internet glitch. Let me try to read from the chat box again. Please. Okay, that is somebody. Okay, somebody is requesting for the slide. Oh, you will definitely get it. The slide are loaded and you can have that. Now, that is Dr. Abdullah Mohammed. Your hand is up. You can unmute yourself and ask your question, please, Dr. Abdullah. Go ahead, unmute yourself and ask your question.
Thank you very much, sir. Thank you for the very wonderful presentation, sir. Sorry, please, concerning when you have different variables, can you hear me, sir? Sorry.
Yes, you are audible. Go ahead. Thank you,
Okay.
Dr. Man.
So wait, when you have different variables that some are normally distributed and others are not normally distributed, how do you summarize those data? For example, I'm looking at 6 domains in quality of life, and then maybe 2 of those domains are normally distributed, and then the remaining 4 are not normally distributed. So will I report mean for the 4 and then report median for the remaining ones? Is it acceptable like that, sir? And then
thank you for the question. Okay, go ahead.
Sorry, sir. And then the other question is there a certain number of categorization that is acceptable for analysis? I mean, like I'm doing a study on skin diseases, for example. So I want to look at association. Do I need to categorize the skin diseases? And then what is the acceptable number of categorization? Because sometimes when you load on XPSS, you see memory, you see just in booting. So is there a certain number of categorization that is preferred for you to have optimal results? Then my last
thank you. Okay, go ahead with the last.
Yes, the last question is on logistic regression. Can you also have an outcome that is large impact and small impact? Is it acceptable apart from yes or no? It's also dichotomous. Can it be large impact, small impact? Concerning quality of life, for example. Thank you
for the questions. I will start from the last. Now, whether you don't necessarily need to use a yes or a no. Large versus small or medium can be used. It's just to categorize. If you want to use logistic regression or binary logistic regression, then you can use yes, no. You can use dead, alive. You can use small, big. You can use low, high. It doesn't really matter. All you need to do is to have 2 categories. Whether it is yes or no, it doesn't really matter. So you can go ahead and use that. Now, you talked about categorization. I would like to advise that the fewer your categories are, the better. Yeah, if you have 2 categories, if your outcome are in 2 categories, that is when you can use binary logistic regression, because the outcome has to be the outcome has to be dichotomous. Now, talking about your independent variables now, the fewer your independent variables are, the better it is for your analysis. Instead of having like maybe 6 different categories of probably skin diseases and so on, if it's possible for you to recategorize them and have them like 2 or 3, better. If you can not do 2, if it is 3, it is still not too bad. 3 is better than 4. If you cannot use 2, and out of 6, you can only collapse them into 4. 4 is still better than 6. So the fewer your categories of independent variables are, the better it is. For instance, if your categories are numerous, there are like 6, 5 different categories, you need a very robust or a high sample size for you to be able to conduct meaningful analysis. Oftentimes, when you use chi-square test, maybe in SPSS or in some other data analysis tool, once you use them, you will see the software telling you that the test is not appropriate because you are having smaller counts as expected value in your cells. When the expected value are less than 5 in any of the cells, SPSS would flag it to tell you that may not be appropriate. If it is more than 20% of the cells, you're having expected value less than 5. So if your categories are too numerous, then you'll be having very small counts in the cells, which is actually not the best. So reduce the number of your category to a reasonable extent. Sometimes it is not easy to just collapse your independent variable into 2 different categories. No, but limit it to most allowable and reasonable category. Now, your first question is about the domains of quality of life. And these domains, they are standardized, and that is the way they are reported. And you mentioned some domain, they are not normally distributed. But for the sake of quality of life. When you report some, maybe one or two of the domains are skewed, not normally distributed, I would advise you that because it is QOL and there is a way it is reported, you can still use your mean in this case. When you use your mean, then when you are reporting, you can also report that, made mention that some of the values are not normally distributed, because all you can do is to compare mean only. So you cannot be comparing median, saying, okay, for maybe there's a domain called social domain, you have used median. For another domain, probably environment, you have used mean. So it will be difficult for you to be comparing median and mean. So for it to be comparable, you may need to use mean and the standard deviation all through. However, you need to note it. Sometimes your assessor or supervisor or the person that is probably guiding you may ask you to also use median and range for all. But what is actually allowable for that domain is the mean and the standard deviation, so that you want it to be comparable. You don't want to be comparing apples and oranges. You want them to be in the same unit for comparative purpose, for the sake of comparison. Now, thank you for that question. There is another question. If I have two outcomes of interest in my research, contraceptive use. Okay, I think that was the question that we talked about earlier on, that multi-level analysis may be good for that particular one. Thank you. The question is from one of my colleagues. Now, how do you know if data is normally or not normally distributed? Is there a statistical procedure to determine that? Oh, I'm sorry, I had a slide, it's not on this system, to demonstrate normal and skewed. Now, what you can do, when your data is normally distributed, there are some qualities that the data must have. Statistically, they tell us that the mean, the mode, and the median, they should be almost the same. They may not, when you say the same, it doesn't mean if the mean is 2, the median should be 2 and the mode should be 2. No, they should not be far from each other. That's actually the way it is explained. So if you see that your mean, mode, and median, they are very far apart from each other, then your data is definitely skewed. Now, you need to determine whether it is skewed to the left or skewed to the right. If your mean is greater than your median, then it is skewed to the right. If your mean is less than your median, it is skewed to the left. But the other thing you can do is to use test of skewness. It's in SPSS, you can just put your data and look at it, or you generate your mean, mode, and median. One simple thing I do sometimes is that anytime my standard deviation is close to 50% of my median, then I need to test that data further. It is likely to be skewed. Let me repeat. When you want to use mean and standard deviation, and you notice that your standard deviation is close to half of your mean, most times that data set is skewed. So you need to check it further by looking at your mean, mode, and median. Merely looking at the mean, mode, and median, I can tell you can tell whether a data set is normally distributed or not. Or you can use the appropriate test in the data analysis software. Now, someone asks again that in case the distribution is skewed, I would like to know if it is preferred to normalize data and use parametric tests. Thank you. That is good. When your data is skewed, you can normalize it. They do this in the laboratory. Most of some colleagues who are laboratory scientists, most of their data sets, when it is skewed, they can normalize it. They can use the log. They can use some other means to normalize it. Then after normalizing it, they will use parametric test to test it. Now, the question continues. Due to some challenges navigating through the non-parametric test analysis and the relative deficits of literatures as guide on them compared to, okay, maybe that's the reason why you are suggesting to use parametric instead of non-parametric. But parametric tests too, they are there. You can use them. They are in the literature. There are guidelines and so on and so forth. Now, there is another question saying that if you have a time in the future, may the webinar focus on, okay, advanced statistics and the assumption. Oh, fine. We can actually do that. Now, one of my colleagues' hand is up. Dr. Yesuru Karim, you can unmute yourself and ask your question, please.
Okay, thank you very much, Prof. Sir, for this very educative and enlightening presentation. I sincerely appreciate you for all you do. I want to make a clarification, particularly the question that I asked. For my dissertation, I had most of my data were actually non-parametric, and I went ahead and used I used Whitney U, I used Kawalis and some others instead of ANOVA and all that. And I must say that I actually had a lot of challenges, particularly when you want to compare with literature. Most of the studies are going to be seen talking about people that use parametrics. So when I now consulted a statistician, I told him that, well, that it will have just normalized, even though normalization will not give you the exact value, but it will have made my work easy. So that was why I asked. Then on the question about quality of life, so I also studied quality of life. I used the whole ODE. Then I also noticed that I think I had 6 domains, and I think 4 were of normal distribution, while 2 were, and I usually use their mean scores. But I was now asking myself that since this particular, so the person that I consulted actually helped me to those 2 that were not that were skewed, he normalized them, so then he used mean scores across the whole of the 6 domains to make the comparison easier. So I wanted to clarify that along with my previous question. Thank you very much, sir.
Okay. Now, I have actually answered the first question. Now, what I think we can do, or you can do in that case, is that you can as well still use your mean and for comparison purpose, and you will note that somewhere. Then, if it's possible to normalize, well, I'm not too familiar how that was done in that particular instance. Well, if a statistician advised you to do that, I'm sure that the person must have checked the literature and see that that is also a feasible way to approach that. Thank you. I think I've already talked about the other question. There are 3 other hands that are up. Let me start with Badru Lawa.
Hello, good morning, sir.
Good morning.
Thank you for the presentation and your usual tutorial. So the person that asked about the categorization of maybe a variable, like did a research on skin disease. So when he categorizes the different types of skin diseases, he's having almost about 8 or 9 different categories. Because if he's to mention all the skin diseases that he saw while doing the study, I think there are more than 20. So when he categorizes them into maybe papillosquamous, maybe autoimmune, and it now amounts to about 6 or 7 variables. And along the line, we'll be checking the factors associated with the skin diseases and relating it with the quality of life and the type of skin diseases. So meaning that it's going to be using a chi-square or maybe ANOVA. So in this instance, so when we run the chi-square, maybe we put all the categories, maybe 7 by 2. So it takes time, and sometimes it will be telling us some result is not normal. So that was why I was asking that, are there limits to the number of categories in instances like this, where the categories, and from literature, you see that they categorize into about 6 or 7 types of skin disease. So do we just go ahead and use our 7 by 2 table? And also for the categories and if you are comparing it with the domains, since the domains is in is a continuous variable and the categories maybe 7 categories, so will ANOVA still be the appropriate test to use if you want to compare the quality of life across the different categories of skin disease, having in mind that you have almost about 4, 5, 6 categories of domains of quality of life and 7 categories of skin disease? Thank you, sir.
Okay, thank you once again for the question. Now, I started by telling you that the fewer your categories are, the better it is. The fewer your categories are, the better. Now, if you have 6 categories, it's better than 20. Now, if you can also reduce the 6, it is also better, because if your categories are too many, then at the end of the day, you may not be able to do bivariate analysis. You may end up ending your research at descriptional level. just descriptive statistics or descriptive analysis. Now, what I think our advice is that if the 6 types of 6 clean diseases, if you cannot summarize or try to recode them and reduce them further, you can use them as they are. Now, if you are comparing 6 categories and the cells are having small numbers, and the software telling you that, oh, no, this may not be doable, should not be doing this with that is not allowed, then at that point, it's telling you something that is a need to, if possible, compulsorily collapse the category. Now, when you are collapsing them, you may look at what is similar, what is common amongst them, and use that as your basis for the category. Another thing is that you can go back to the literature and look at people that have done this study. I want to say that there is no study that you are doing that somebody has not done something close to that in the past. So you may need to go back to the literature and see exactly how it has been done. Now, when you want to do multivariate level analysis and your outcome is in about 6 different domains, and your independent variable is also 6 categories, I think for you to have meaningful statistics at that point, I will advise you that you take the outcome one by one. You may not need to use the 6 domains at a time. You may look at the general quality of life by pulling the 6 domains together so that you have a general quality of life. Then if you are able to have that, you can use the general quality of life as the outcome for that level analysis, or you pick the domain one by one. But if you do that, you have 6 different results at the end of the day. So you may look at which of the 2 is actually feasible or is better. So, when it comes to statistics, you need to go back to the literature, see what people have done, see what is feasible, discuss with senior colleague, and so on, before you make up your mind on exactly what to conclude or what to do finally. So it's either you separate them, domain analysis, domain by domain, or each domain, who has good, who has poor, or you pull the 6 domains together and you have an overall quality of life that you will use for the analysis. So that's a way that I think you can do that. So thank you so much for the question. Now, the next person, Mojisola Aleriya, one of my sisters.
Okay, thank you very much.
Oh, thank you.
Yeah,
You're welcome.
very much. So I was going to ask the question about contraceptive use and intention to use as my outcome of interest. So for intention to use, I was just wondering if you can help shed more light on how do I measure intention to use? Because my research is quasi-experimental, so I'll be having quantitative variables and quantitative research and qualitative. So I'm just trying to see how can I measure intention to what do you think how can I measure intention to use? What's the best best way to go about it?
Okay, thank you for the question. Well, I think it's something not so difficult. Now, some people, you have your tool ready for the study, and your tool for intention to use, those people are, some of them are using, some of them are not using, but they have the intention to use. And I think the DHS also has a variable on that, if you are familiar with the demographic health survey. So I may advise you to just take a quick look at the demographic health survey, and maybe Anu can also maybe shed light on that. And I think there is another hand, one of my colleagues too.
Thank you very much.
Shed light on that rather than asking questions. So let me allow the co-host to shed some light on that.
Okay, thank you very much, Dr. Elisami. Thank you to the person who asked the question. Yes, so far, there is no standardized means to check intention to use. And currently, I think recently there was a meeting, a DHS meeting, where they were trying to look for a way to capture or to bring in some additional questions, including this intention to use. So personally, I conducted a study at a point, and one of the variables I measured studies, or within the context of a few other studies where they had tried to measure intention to use. So I had only used a few questions. So I think one or two, would you consider using a contraceptive method? So that was the question I asked. And then I disaggregated among current users and those who have discontinued contraceptive use and those who have never used contraceptive methods. Yeah. Thank you, sir.
Okay, thank you. I appreciate that question. She works in the contraceptive domain, so she understands when it comes to analyzing contraceptive data and the like. So let me allow Dr. Olukemi Olubade to also shed more light on that. I'm sure she's not asking a question. Over to you, please. Unmute yourself.
Okay, good morning, everyone. Thank you very much, Dr. Ilesomi, for the very valuable presentation and contributions from everyone. So I have a comment, and I actually need a clarification on something I'm working on. So the comment is for the person that was asking about normally distributed data and all that. There are other ways if you want to be very sure about how well distributed your data is. You could also do a test of normality if you are using SPSS. It's an option that is on the software, and then there are steps you can use to to verify if you are not very sure whether your data is normally distributed or not. Or you can actually generate a distribution curve on SPSS as well and see what the curve looks like. So from the features of the curve, you'll be able to, actually confirm that your data is normally distributed. And then you can go on with your analysis, depending on your conviction. And you must also communicate that while you're writing your reports. Then on intention to use, so it depends on the setting, the age group, and also what other questions or variables that the study is looking at, because there are certain situations where you could generate variables yourself based on maybe recommendations from previous studies. So if the researcher, the person who asked the question, has more recent literature, those could have said, oh, when it comes to intention to use, this other variables should be considered or should be looked at. So you can look at recent studies that have been done and look at the justification for their study, how they carried out their study, the variables that they used, and maybe recommendations for future research. And then you could incorporate that in your study, justifying why you added those variables. Okay, now the clarification I need is about, I'm doing a cross-sectional study, or rather, I've even done the study already. And then I saw that the data was not normally distributed. And so I reviewed, information online, and I saw that they said chi-square test is also a non-parametric test, right?
Yeah.
So by the time one now wants to do multivariate for that kind of study design, what, in quotes, non-parametric test should one now use? Thank you.
Okay, thank you for the question and also for the input to the other questions asked by colleagues. Now, by the time you get to the multivariate level, then at that point, most times it doesn't really count the distribution of your data, because now something I didn't really talk about, before you go to the multivariate level, you need to look at your p-value. You need to look at your findings after your bivariate. So if you have done your bivariate, whether using parametric or non-parametric tests, then at the level of the multivariate, there are some other factors that will consider whether you will continue with multivariate or not. For instance, if you have done a study and at the end of the day, nothing was close to being statistically significant, let's say at 10%, for instance, then in such a study, you try multivariates over and over, you are not likely to find anything. Now, let's assume that you have done a study and the variables are very few. At the end of the bivariate, you got only maybe one thing that was kindly statistically significant. Then at the end of the day, you don't really need to do multivariate for that. You can do your multiple analysis that will give you, or the analysis that will give you odds ratio and confidence interval as well, but not multivariate, because it is only for one variable, which is an unadjusted odds ratio. So you can just go with your unadjusted odds ratio and report if it is only one variable. But if you have done your bivariate and it is non-parametric, when it comes to multivariate, the distribution has little or no input into deciding whether you go for multivariate analysis or not. So thank you for the question.
Okay, I still have an additional comment. So thank you, sir, for that response. So for this particular study, there were actually quite a number of significantly associated, there were quite a number of outcomes that were significant at, the p-value significance, yes, bivariates, about 5 of them. So for multivariates, how should one then proceed?
Okay, now, if I may ask, in all, you have up to how many variables in your bivariate that you want that you have that 5 from?
About 10 variables, and then about 5 were now statistically significant.
Okay, now the first thing you can do, there are several ways to approach that. The first thing you can do is to select the 5 variables that are significant and put them into the logistic model and see how it looks like. Now, when you do your logistic regression, I would like you to check your goodness of fit, maybe your Small-Lemshow test, to know whether the variables are well fitted. Now, another thing to do is that variables that are significant at least 10%, most times you use a P of 0.05, that is 5%. You may increase it to 10%. So that those who have the chances of being significant, you don't lose them out in your logistic regression. That is the second thing you can do. Now, the third level is to put all your variables in bivariate to push them into the multivariate analysis model. So you can push all. I started by saying that you pick those ones at 5%. Since you have 5 already, so going with 5%, I think that should be okay. But assuming it's not up to 5, then you can be thinking of, let me increase to 10 so that we see what are likely to be. Or you can push all of them. Then when you push all your variables into the logistic regression model, you now start to be looking at the goodness of fit. You look at which variable can you remove to have a better fit for the model. You keep on checking your Small-Lemshow test of goodness of fit, and you keep on checking your -2 log R. So once it is improving, you can remove, it's just like removing a variable, putting another one. So by the time you are removing one, putting another one, so you are testing which one. And there are also commands in Stata and also in SPSS that will generate all the possible model just by a click on Stata. All the possible models will be generated once. All you will now need to do is to be looking at the -2 log R, the Small-Lemshow goodness of fit to determine which of the model you should report in your results. It will even give you the best model, the final one. So it's either you use that or you do it manually by removing some model that you think that they are not having a good fit for the analysis. So either of the 3 methods should be fine for the analysis.
Thank you very much.
Yeah, you're welcome. I think there are 2 more hands before we round up. Olayinka Ibrahim, over to you, please. You can unmute and ask.
Thank you, Prof, for this very beautiful presentation. Indeed, I really gained. I have 2 questions. Recently, I have a reviewer comment, and I think the model I was trying to do a 2x3 tables, and some of the tables they were very small, so the number of the cells were very small. So later on, I used something like G test for chi-square. Though I use it probably to respond to the reviewer comment, it wasn't really. I need a bit more to shed more light on it, because I was surprised that it's not really very common among people using it. The second one, so that I will just take it. there was a model I also tried to use to do like a kind of logistic regression, but one of the reviewers is raising the question that how did I handle the issue of multicollinearity? So how did I handle the issue of multicollinearity when I try to do the binary logistic regression? Considering that some of my independent variables, they themselves may be related, I think I need to help me shed light on these two areas.
Yeah, thank you so much. Now, the first question, sincerely, I'm not familiar with G-test for chi-square. I'm not familiar with that test. It's fine. I think I'm going to also check that up. I keep learning too. So I'm not familiar with G-test, but what I would advise is that for your independent variable, is it possible for you to dichotomize instead of having it in three categories?
Okay,
So that
okay, I think that's another.
Yes,
Sure,
if
sure,
it is possible
sure.
to do that, yeah, you may get something better. Now, if you can't use your chi-square, then you can use another form of test instead of just the chi. So that if you dichotomize and your table becomes a 2x2, then you can move ahead and do your test. Now, talking about multicollinearity, if you do your test, you can actually check for multicollinearity. One, manually, you can determine what is likely to be the same or what is going to give some level of the same results in your independent variable. If part of your independent variable is level of education. Now, I'm just using this as an example. Level of education may be primary, secondary, tertiary was part of your independence. And at the same time, there is another variable that is collinear with level of education, maybe any professional qualification, for instance. Now, mind you, people with university education who have a graduate degree, they are more likely to have professional qualifications compared to someone with secondary school level of education. That's just an assumption, which I think is likely to be right. So at the end of the day, those two questions, they have examined the same thing, either directly for one and the other one indirectly. So if you have these two model, these two inputs or independent variable in the same model, what some models will do is to remove any model that is causing multicollinearity. They will remove the variable for you. Anyone that is causing multicollinearity will be removed immediately. So that is one. Now, you also can do manual looking at the independent variables and any of them almost repeating or measuring the same thing. So you can also remove that yourself. But most of the statistical software, it will remove, and it can do another one that will not remove it. So by the time you see the one where those multicollinear variables are removed, there will be a better fit compared to where you added them forcefully yourself or where they are not removed. So what I think you need to do is to repeat the analysis over and over, put all the variables, remove the ones that are multicollinear, and check their goodness of fit, and check their minus log R, how large or small it is, so that it will guide you in determining the best fit. I'm sure that the best fit is the model that does not have that level of multicollinearity. So analysis may take you to go back and forth over and over, looking at the same thing again and again for you to be able to determine which direction to go. So thank you. I hope I've been able to shed some light into that. So, yeah, sure. And the last question for today is from Laura Mahmood. Please unmute yourself and ask your question, please.
Okay. Good morning, sir.
Yeah, good morning. You.
Thank you very much for the lecture. I really appreciate. Please, I have a question. I have 2 or 3 questions, please, concerning my dissertation topic. The topic is sexual behavior and contraceptive use among HIV-infected women attending the HIV clinic. So one of the challenges that I have is how to assess the questions I have, how to assess the sexual behavior. I just have like 2 questions. I don't know if they are okay. Sir, can you hear me, please?
Yes, you are audible. Now, to keep in something before you continue. Now, for you to know whether your questions are okay, it's not ideal for you to just sit down and write your questions and say, oh, these are the questions I want to use to answer this objective. No, I would advise, I know you must have done that, but you can't do it too much, or you can't do it enough, kind of. You can still go back to the literature, see the studies that have been done on sexual behavior. How have they been asked? The questions, how have they been asked? I think that will help you a lot. Now, if the way the questions have been asked will not be suitable for the environments where you are, then you may need to modify, and then you need expert opinion in being sure that, oh, these questions are okay to answer the objectives that you have. So you can't just put down your 2 questions and then go to the field like that. You need to consult literatures, seek expert opinion, and then try to, if possible, get some validated to guide you. You can continue, please.
Yes, sir. Thank you, sir. So I actually contacted and I saw some questions that some people that did similar, and those were the questions that they used. So, but I actually couldn't find any like a validated questionnaire on the sexual behavior. So I just had to choose from the ones that I saw. So, and also, so I'm also having challenges on like what statistical technique should I use to analyze my data?
Okay, now just like the session that we just had, your outcome will guide you in knowing exactly what you do. If your outcome is contraceptive use, your primary outcome, the contraceptive use either yes or no. Now,
yes,
that is a qualitative outcome. You are reporting in frequency and proportion. So for that, if you are doing bivariate, depending on the sample size, which is robust enough, chi-square test will be fine. You are not comparing mean. What you do is compare chi-square, and once you have more than 1 or 2 independent variables, you can go to your multivariate analysis as well. So I think it's almost as straightforward as that. But your outcome, as I said, determines your choice of test statistic for the study.
Yes, sir. Please, sir, one of my objectives is to determine the relationship between contraceptive use and sexual behavior. Will that still, with the chi-square still be?
Now, out of the 2, I will ask you a question, then your answer will determine my further response. To determine the relationship between sexual behavior and contraceptive use, out of the 2, which one is your outcome? And I have my answer, really. The outcome to me is contraceptive use.
Yes, sir, that's yes.
Now, I want you to run away from the word to determine the relationship. Relationship is an English word, kind of. In this setting, you need to be more specific.
Yes, sir.
So maybe you may need to change the term. Relationship may be factors, it may be correlation, it may be, so it can be slightly confusing. So you may need to change that word. I'm sure the outcome is still contraceptive use, which is a yes or no response at the end of the day. So I believe that what the explanation I gave earlier should still suffice. You can still use it using the bivariate analysis, using chi-square, depending on your sample size and how robust your cells are, and then you move on to your multivariate. You can do binary logistic regression. That is, your outcome is dichotomous. Your binary logistic regression is okay for the analysis.
Thank you very much, sir. I really appreciate it.
You are welcome.
Excuse, so I would like to do. Excuse, sir.
Okay.
Excuse,
Go
sir.
ahead. Go ahead.
I think the sexual behavior in this instance, she has 2 questions. I don't know what the question. So if she now wants to do a bivariate, which of the question is she going to use, and what does each question mean? So is it going to just select one of the questions, or is she going to use the 2 questions to do the bivariate analysis, which is the chi-square?
Yes,
and if she wants to do a binary logistic regression, because the main objective from her is sexual behavior and contraceptive, the main aim, sexual behavior and contraceptive use. So if she wants to now do a logistic regression, so and she wants to check the independent predictors of contraceptive use, so is she still going to put all the 2 questions is it going to control for all the 2 questions, or she's going to use one of the question of sexual behavior? Thank you, sir.
Yeah, thank you for clarifying that. Now, in this particular question, we are seeing sexual behavior as an independent variable, not an outcome. But if sexual behavior is also an outcome, then she needs to identify a primary and secondary outcome. But from what she said, she's using contraceptive use as the main outcome of the study. So that the independent variables are more like the predictors, what we use to determine what predicts contraceptive use. So the independent variable will include the sexual behavior, except if sexual behavior will be used as an outcome on its own. But to find the relationship between the two or the association, the sexual behavior has to be seen as independent variable. Now, in some analysis, your independent variable, one of the independent variable may be your secondary outcome. So if sexual behavior is a secondary outcome here, then it can also be added to the independent to find the association, or it can also, the independent variable can be analyzed using sexual behavior as its own dependent outcome. So it depends on how she actually wants to go about the study. But the first thing is for her to understand the independence and the dependence variable. So if what you have explained applies, then you can, your approach can actually also be considered. Thank you.
Yes, sir. Thank you, sir. The independent variable is still the sexual behavior, just that she asks only 2 questions on the sexual behavior. So I
Okay,
don't know
that means contraceptive use. Yeah, sorry
yes,
for
it's still
interjecting.
dependent variable. Yes,
Contraceptive use will be an independent variable. So now
no, sir, the
there is
contraceptive use is the dependent variable.
contraceptive is the dependent.
Is the dependent.
Sorry, let's use the word contraceptive is the end point, is the outcome, right?
Yes, sir, it's the outcome variable. Yes,
good.
Sir. So while
So
sexual behavior is the predictor, but she only asked 2 questions. She did not score the sexual behavior or categorize the sexual behavior. She only asked 2 questions, question 1 and question 2.
Thank you. Now there may be a need to do more literature search so that sexual behavior can be elucidated or assessed using appropriate questions. Some questions can be answered, just one simple question can determine some independent variable. It's not all the time that you need to ask a lot of questions to do scoring before you arrive at a variable or the independence. But I will advise and maybe refer you back to the literature so that you check the literature and see how best to go about that. So thank you once again for the good job or good work that you are doing. So I would like to hand over back to the moderator. I think we've passed the hour for like 38 minutes. So back to you, moderator. I hope she's there.
Okay, thank you so much, Dr. Elesomi, for the amazing session you expertly delivered. We are grateful. Senior colleagues and colleagues, please let's appreciate Dr. Elesomi for his time. Let's use the emojis as we show him our appreciation and gratitude. Yes, so next week Saturday would be having an exciting session. I just want to share the screen briefly, and it will be delivered by Dr. Mojisola Oluwashanu, and it's titled Aligning Research Objectives with Theoretical and Conceptual Frameworks. Aligning Research Objectives with Theoretical and Conceptual Frameworks. In that session, we are sure that everyone who participates in that session would understand how to frame or how to prepare or design their conceptual framework, integrating the different variables they would be using and showing the interrelationship so that this guides the work going forward. Yes, we'll share the link in the chat box so that those who want to register immediately can register. Okay. Okay. So with this, we have come to the end of today's session. We appreciate everyone who took their time to join us in today's session. Thank you so much. As announced, we'll meet again next week, Saturday. Plus-Circle is the Plus-Circle Community Health Advancement Organization has been the coordinator or the mastermind behind this program, which has actually been opening our eyes day by day on research-related matters. So please tell a friend to tell a friend to tell a friend. Research is doable, research is possible, research is interesting once one receives the guidance that is needed. All right, and we look forward to seeing you next week, Saturday. Till then, do have a restful weekend. Goodbye.